Hi, my name is James Pope. I'm a lecturer in EMAT, data science. So I said this one's titled Pervasive Health Machine Learning. I didn't get much time to get a lot of pervasive health in there, but maybe to describe it a little bit. We're talking about things generally before you talk to your GP while at home, wearables, things like that. Certainly cameras could be involved, these sorts of things. So hopefully there we go. So we've been using this in other areas. I've been using it quite a bit in cybersecurity, but I would prefer to apply it to basically detecting cancer. So as an example, one of the techniques that we're currently using are graph neural networks. And as you can see here, often data comes in a graph form. And generally what we've done previously is we would then extract that into a tabular form and then run our favorite machine learning algorithm on it. Doing that, we lose a lot of information. And so what we prefer to do, and actually the latest techniques actually take the graph as input to the neural network. So we can actually make inferences on the graph. This is an example of detecting an anomaly between these two nodes. That could be something, again, in different contexts. This one, again, with cybersecurity. But obviously there's also a time component as well that you can imagine. And they've now actually been combined. So these spatial temporal graphs are being used, and at least within the last 2 or 3 years have been used successfully to detect lung cancer, breast cancer, and brain cancer. So these also, I don't want to say that they're interpretable, but obviously there's a little more information that comes out of the model when you look at it this way. So that's one of the techniques I'm interested in, actually, as applying to, how can one say, it's a solution in search of a problem. So in any case, one thing that's a bit more concrete with my research is I've been looking at skin cancer images. As previously mentioned, this is in some sense a success area, being able to detect the images. And as you can see here, you get a picture of a mole and detecting whether there's cancer or not. We're specifically working with the Gene Golding Institute with Hugh and Mohammed Hassan, who are in the room. We're looking at tone bias, but nevertheless, taking these images combined with other data, multimodal inferences can certainly help detect these this much earlier. And so one thing that would be interesting that I at least thought would be looking at, for example, in children, there seem to be a lot of false positives and increasing that the accuracy of that. The point is that I need clinical support because I think that's interesting, but I don't know that that's actually interesting. And so really looking for clinical support on this. So that's it. Thank you.